In this final example, we have two triangles that are both touching along this line segment, which is labeled X. And we're asked to find the values of X and Y. So let's look for some special triangles here. Well, I see I have a right angle here, so this must be a right triangle. And I have a 30-degree angle, which tells me that this angle that's not labeled must be 60 degrees, and that this is a 30, 60, 90 right triangle. I'm also given the measure of the hypotenuse. Okay, so our theorem says that the hypotenuse measures 2 times the measure of the shorter leg. I'm writing this out in words because here we've abandoned the A, B, and C notation that we were using in the last few examples, and sometimes we need the words to remind us how to use the theorem correctly. So the hypotenuse we know is 8. The measure of the shorter leg in this triangle is what we're looking for. The shorter leg is always opposite the 30-degree angle in a 30, 60, 90 triangle. So we have 8 equals 2x. Now it's easy to see how we can solve for x. And we have x equals 4. Okay, that wasn't so hard. Now we're asked to find y, which is the measure of this portion here. Okay, we have another 30, 60, 90 triangle here because this is also a right angle. And here's the 30-degree angle because 90 plus 60 plus 30 adds up to 180. So we're asked to find y, but we already know x. X equals 4. So we're going to reuse the same special triangle theorem, only this time we're dealing with the two legs. So the second part of the theorem says that the long leg is the square root of 3 times the short leg. Here, in this tiny triangle, x is now the longer leg because it's opposite the 60-degree angle. X was the shorter leg in this triangle, but it's the longer leg in this triangle. So now we're going to plug in 4 for the measure of the long leg since we're focusing on this small triangle. The long leg is the square root of 3 times the shorter leg is what we're trying to find. We're going to divide both sides by the square root of 3, and then we're going to have our answer. Y equals 4 over the square root of 3. But wait a second. Remember the simplest radical form video where we learned that mathematicians don't like radicals left in the denominator. So we have to simplify this answer before it's going to be perfect. So let's take 4 over the square root of 3 and multiply it the way I showed you. We can multiply anything by 1, but we're going to write 1 in the form of square root of 3 over the square root of 3. This will allow us to multiply straight across, get the numerator 4 times the square root of 3, and having this in the numerator is no problem. We're allowed to have radicals in the numerator. Now the denominator, we have the square root of 3 times another square root of 3, which gives us simply 3. Now we've cleared out the radical from the denominator, and this is in simplest radical form. So we have y is equal to 4 times the square root of 3 over 3. Okay, you try one. Find the values of x and y here. For further practice with this, see page 302, numbers 1 to 15 odd, and numbers 21 to 25 odd.